Section 4.1, Commutative, Associative, and Distributive Laws. Continuing on to page 3, I want to go ahead and just show you some more examples of using the new laws and properties, and I'll state which one as we go through. So in this one we have a number out front multiplying this quantity in parentheses, and so we're going to want to distribute that -6 into each one of those pieces, and so we're using the distributive property right there. On the initial step, that would just become -6 times 2x, and then -6 times -4y, and -6 times +5. And I would go ahead and carry out each of those multiplications. So when I do this first one, I'm going to do -6 times 2x, and the -6 times 2 is -12x. And then here, -6 times -4 is +24, and the y would just stay there. And -6 times +5 is -30. So thinking about all the properties I used on this one, the distributive property was the big one, where I distributed the -6, and pointing out that we can do that with multiple terms. It doesn't just have to be 2, and it's okay if one of the pieces is subtraction, you can still distribute. But the other property I used, I would say, is also the associative property, because if you look at the way this is written right here, it's the 2 and the x that are together, but what I did was multiply the -6 and 2 to get the 12. So just bringing in another color just to show you that one by itself. If you have -6 times 2x, what I did there is say that's the same as if it was a -6 times 2 and then times x. And so that is the associative property of multiplication, because I've regrouped it from the 2 on the right to the 2 on the left. So typically a step like that's just going to be a mental step, not one that we write down. And I did that step actually on this one too, because I multiplied the -6 and the 4, even though the parentheses were around the 4 and the y. Bottom line is, when it's all multiplication, it doesn't matter what order you do it in, and that's essentially what the associative property of multiplication is telling us. Alright, let's look at another one. Be careful with this one not to add the 1 plus 5. Remember, order of operations, the 5 times has to happen before the 1 plus. So that multiplication has to occur first. So again, I would use the distributive property. This 1 isn't part of what's being distributed because that's an addition. It's only the multiplication that gets distributed. Order of operations, that 1 comes later. So I'm just going to copy the 1, distribute the 5. So 5 times x is 5x. Plus 5 times 3 is 15. And then I want to add the 1 and the 15 together, but they're not next to each other. So most people would just go ahead and add those and say, alright, we have the 5x, there's no like term, I'll copy that. But the 1 plus 15, that would be plus 16. But what property allows you to add the 1 and the 15 when they're not next to each other? And I would say that's probably a combo of the commutative and associative. Let's go ahead and look at some in-between steps. These are steps you don't have to show, but I want you to see how these properties really are involved. Let's see. I could go ahead and rearrange these two and say this is 1 plus 15 plus 5x, and I would say that that is the commutative property of addition, because I took these two pieces and switched them. And then working from left to right, 1 plus 15 is 16 plus 5x, and then lastly I could switch them back. So actually this could be done with the associative property, but I managed to do it with just commutative. I switched the order of these two, that's commutative property of addition. Then I worked left to right, which is normal order of operations, and then I switched the order back to get this piece. So this was commutative when I switched these two, and this was commutative when I switched them back. And again, most people, that all just happens mentally. They just see the 1 and the 15 and it's all addition, so they add those two together. And that feels right, but what are the properties that say it really is right? And it turns out that would be the commutative property of addition. Alright, let's go ahead and look at another one, part I. Again, we've got this multiplication with the distributive property, so I'm going to distribute this. The key thing to notice here is what I'm distributing is not a 5, but a -5. So I'm going to write this one out. That would become -5 times 2x, and then -5 times -3. And the plus 7 does not get the 5 multiplied by it. I'm only distributing to the stuff that's in parentheses, and the 7 is out. So that just stays as a plus 7, and we'll deal with that later after we've worked out these other pieces. So that was the distributive property right there. And then negative 5 times 2 is negative 10x. And just like up here, that's actually using the associative property, but I'm just going to do it mentally rather than write it out. And then negative 5 times negative 3 is plus 15. And then we have a plus 7. And most people then combine these without giving it much thought, and I'm going to go ahead and do that too. Negative 10x, and then 15 plus 7 is plus 22. But the truth is that we used one of the properties right there as well. We used the associative property of addition. We use the associative property of addition here because if you were to follow order of operations on this step right here, you're supposed to work from left to right, which means we should do negative 10x plus 15. But we don't know the answer to that, so we'd be stuck. So what I did instead is I added these two together first. And so even though normal order of operations says go from left to right, the associative property says parentheses are on the left could be moved over to the right when it's all addition, allowing me to ignore that left to right rule because it's all addition. So when you don't go left to right on something that's all addition subtraction and you do some other order instead, that's the associative property of addition that you're using right there. Alright, let's look at another one. On part J, we just have a negative sign in front of the parentheses, and I want to distribute, but what do I do when it's just a negative? So what we want to do is think of that negative as if it was just a negative 1 times 4x minus 3y. So if you just have a negative sign in front of parentheses, it's the same as if you had a negative 1. And then when you think of that as a negative 1 times, all of a sudden, because it's a multiplication, the distributive property applies. And you do negative 1 times positive 4 is negative 4x, and negative 1 times negative 3, those two negatives make a positive, and you get 3y. So if you want to distribute a negative sign and you want to think about the math on that, you make it a negative 1 and use the distributive property. If you want to do it quickly and skip the middle step, then you'll notice that what happens when you distribute a negative, because it is multiplying by negative 1, you just end up changing the sign. So the positive 4x becomes negative 4x, and the negative 3y became a positive 3y. And that's always the effect that you get of distributing a negative 1. So a lot of people will just skip from here straight to there without showing the minus 1 step. Alright, let's go ahead and move on. So this is just that same principle again. We have that negative in the front, so I'm going to distribute that, and this time I'll do it the faster way. I'm just going to use that negative to change both signs. So this positive x becomes negative x, the positive 1 becomes a minus 1. And then what I want to do is combine the 4 and the minus 1. Let me go ahead and show you some of the steps here, even though we could just do them in our head. I'll go ahead and rearrange things a little bit. So when I do that, if I'm rearranging, that's the commutative property, and the addition subtraction, we think of all that as addition. Remember, subtraction is just adding a negative. So I would say that was the commutative property of addition right there. And then if you look at this, the only things I could combine are the 4 and the 1, but that's not left to right. So in essence, I want to treat it like there was parentheses right there and work on the right first instead of on the left, and that's the associative property of addition that says do it in any order you want when it's all addition. So that becomes negative x, and then 4 minus 1 is plus 3. So that would be the answer to that one. Alright, let's look at a final one. This is one we've already been looking at, the distributive property, but what do you do when there's a fraction? And the answer is, well, same thing as you do with any number, you distribute it. The only thing that might be different is a little harder to just do that quickly in your head, so you might end up slowing it down a little bit, taking your time, showing a little more work. So this would be 2/3 times the first term, 6x, plus 2/3 times the second term, which is a 9. And then because these are fractions, you might want to make the other two fractions, so I'll put both of those over 1, and then I can start thinking about some canceling. This 3 goes into that 6 twice. This 3 goes into that 9 3 times. And then I can multiply the leftovers. 2 times 2x would be 4x. On the denominator I still have a 1, but if I only have a 1 I don't need to write that. And then 2 times 3 on the numerator there would be plus 6, and in the denominator all that's left is a 1. So the simplified version would be to write those fractions without the 1 in the denominator. So distributive property still works the same for fractions as it does for integers. It's just the multiplication won't be quite as fast, so you might need to write it out a little more carefully and show your work. just to make sure that you get through smoothly on the fraction problem. So on this one and this one, we had a negative that we distributed, and I said the way you do that is you deal with it as if it was a negative 1 times. And this property is just stating that right here, that if you have negative 1 times something, that's the same as if you just had a negative. And if you look at what we did up there, we really used it in the other order. If you have a negative in front of something, that's the same as if you had negative 1 times that thing. And then remember, in the case of the parentheses, what effect does that have when you distribute that negative? It just changes the signs of the stuff that's inside. So positive, negative became negative, positive, and here they were both positive, and after distributing the negative, they were then both negative afterwards. Alright, continuing on to page 4, I just want to show you a little bit of calculator stuff here. First thing they want us to do is simplify these expressions, and that's fairly straightforward to do. This is, most of us would just go straight to 15x on this. I'll show you the property again since the properties are new. We could move the parentheses from the right side to the left side and make it 3 times 5 in the parentheses and then the x. And then 3 times 5 is 15, and the x is still sitting there, so we get 15x. So that's just the associative property of multiplication, changing the order from working on the right first to the left first. And then this one, distributive property, very straightforward problem, pretty simple numbers. 5 times x would be 5x, minus 5 times 7 would be 35. So here's one where we're using the associative property of multiplication, another one with the distributive property. Nothing too complicated there. I just wanted you to see something new, which is how you can check your work by evaluating something they're asking us to do. And the idea that they have there is that you can check your work by plugging a number into both the left side and the right side. So there's the initial work. Now let's look at the check. When you go to check by evaluating, don't use a number like 0 or 1. Pick something a little different. Let's go with, say, x equals 4. So I'm just kind of pulling that out of thin air, but it's not a good idea to use a 0 or a 1. So I'm going to plug in x equals 4 into the left. So the left-hand side becomes 3 times 5 times 4. So what would that be? In parentheses, 5 times 4 would be 20, and then 3 times 20 would be 60. Now if I've done a correct job of simplifying this, I'll get the same thing if I plug 4 into the right-hand side. So let's test that. Right-hand side would be 15x, or 15 times 4, but 15 times 4 is 60. So the fact that when I kind of picked a number out of thin air and it gave me the same answer on the left and the right is a good sign that I've simplified that correctly, and that's what they mean by checking your work by evaluating, is just plug something into both the left and the right, see if you get the same thing. If you do, it's a good sign. So let me do that again for B. I definitely consider this an optional step, but they're going to state that to you in my math lab, so I just want you to see what they mean. So x equals 4, there's nothing special about that, so let me just pick something different down here. We'll go with x equals 3, just so we're varying it a little bit. And on the left-hand side, we would have 5 times 3 minus 7. Work inside parentheses first. 3 minus 7 is negative 4, and then multiply 5 times negative 4, you get negative 20. On the right-hand side, if I plug that same 3 in, I get 5 times 3 minus 35. So I do the multiplication first, 15 minus the 35, and 15 minus 35 is also negative 20. So again, just kind of picking a number somewhat out of thin air, plugging it into the left and the right. If you get the same number on both sides, that doesn't prove you simplified it correctly, but it's a good sign, because they're supposed to be equal for any value of x. So if you just kind of pluck a number out and it works, good indicator. Alright, let me go ahead and show you another version of that uses the calculator. So let's simplify the right-hand side and then graph by hand and also check on the graphing calculator. So when I go to simplify the right-hand side, I want to use the distributive property on this because of the multiplication. So I get y equals negative 4 times x, which is negative 4x, and then plus negative 4 times 2, which would be negative 8. So if I've used the distributive property correctly, that would be the simplified version. And then this is also, now that I've written it that way, we've got slope-intercept form. So now we're looking at y equals mx plus b. sorry, mx plus b. Let me make that a b. So what does that mean? It means that m is negative 4 and b is negative 8, and b is the y-intercept's y-coordinate, so that means we go through the point 0, negative 8, and we have a slope of 4. And for the slope, that's change in y over change in x, so that's negative 4 over 1. So they want me to graph this by hand. The first point there, 0, negative 8, is kind of a messy one in the sense that it's down 8 units and I've only got 7 squares here, so I'm going to have to number in 2s to get down there. So 2, 4, 6, 8, 10, 12, and so on. So I'll mark the negative 10, and 2, 4, 6, 8, 10 this way as well. And then on the horizontal, I'm going to be only moving over 1 unit, so I can just number in 1s. That'll be fine. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, negative 4, 5, 6, and 7. So I go through the point 0, negative 8, over 0, down 8. And then the slope is negative 4 over 1, so if I go over 1 and down 4, I should be back on the line. So from that spot I'm already at, I want to go over 1 and then down 4. Now this is the tricky part. I numbered in 2s, so going down 4 is 2, 4. It's only 2 squares. And so this would be my new point right here. And then that's going to be the line. So get the ruler lined up, draw that line in. So when they say check by using the graphing calculator, that actually means a couple things. One of the things that I'd be checking when I go to the graphing calculator is just did I do a good job of using the slope to graph this. But the other thing I'd be checking on the graphing calculator, or that I could check, is did I simplify this right. So first I'll show you the part of did I graph it right, and then I'll show you how you check to see did you simplify it right. So I'm going to bring in the calculator, and I'm going to go to the y equals menu, and I want to enter this function. So let's see, what was the function? Y equals negative 4x minus 8. So negative 4 times x and minus 8. And I want to make sure that the window matches up with what I have on the grid. So that's going to give me my best check on the work. So looking at the grid and hitting the window button on the calculator, let me just press enter to lock that in. So hitting the window button, what's the left side of my screen? Negative 7. The right side is positive 7, and the scale I used on the horizontal was 1. On the vertical, I went down as far as negative 14, as high as positive 14, and I numbered in 2s, 2, 4, 6, 8, 10. So, and that's already set as a scale of 2, so I can leave that alone. And I've entered the graph in, so if I hit the graph button, I should see a picture basically like that. And that looks roughly the same. So that's a good indicator that I did my graph right. Now, as far as checking to see did I do the simplification right, here's the trick for that. Go back to the y equals menu, and I've already entered my answer, negative 4x minus 8. Now what I can do is press enter and go down to y2 and enter the original, negative 4, parentheses, x plus 2. If I've simplified it right, then both the expression in y1 and y2 are actually equivalent to each other. And that means that when I graph them, I should get the exact same graph. So let me go ahead and hit graph. And what we should notice is that we only see the one line there. And if I hit trace, it allows me to move around on the line. So when I'm in this spot right here, I'm on y1, which is negative 4x minus 8. If I want to switch to this graph, which I made my y2, I can press the down arrow. Watch here where it says y1, and when I press the down arrow, it changes to y2. But you don't see me move on the graph anywhere. That's because the graphs are on top of each other because this and that are the same. So I asked the calculator to graph 2 lines, and it did it, but it ends up just being one line right over the top of the other. So I'd move to a different x. I'm on y2. Watch this as I move to y1. Nothing happens. The function changes. -4 with the parentheses, here is without, but you still see the same line, same point. So if you think about what we did up here to check our work, we plugged in one number into each side to see if it worked, and then we did that again on this one, and when it matched up we thought, oh, that's a good sign. When you look at the graph of the original versus the simplified version, and no matter where you move on that graph you see the same thing, that's indicating that no matter what x you put in, they're the same. That's a much better indicator that things have worked. It's possible you could make a mistake on a problem like this and just by luck happen to pick a number where they ended up being the same. But if it works at every x, then they really are equivalent expressions. So graphing the two is a good trick for verifying. So while we have this out, let me just go ahead and show you that real quick for this one. So I'm going to go y equals, and I'm going to enter the original 5 times x minus 7. And then I'm going to clear this one and enter the simplified version 5x minus 35. And I'm going to graph the two. So there goes the line. And it's drawing the second one now, but we don't see anything new. So that probably means one is on top of the other. I can't see most of this line, so I'm going to hit the window key, and I'm just going to look down further. Instead of a minimum of -14, I'll change it to -40. That'll just let me see more. So there comes the first line. Now it's drawing the second one, but we don't see anything. So probably that means it's one on top of the other. To verify that, I'll hit trace, move over a little bit so we can see the cursor a little bit more clearly. And when I'm on y1, here's my point, and x and y. If I switch to y2, I'm in the same place. So that is an indicator that the lines are one on top of each other. As I move over and switch from graph 1 to graph 2, I'm still in the same place. Why is that? Because this and this are the same. So when I make a graph of y equals this and another graph of y equals that, I'm really just making the same graph twice. So that's a really good check on simplifying. Alright, that's it for section 4.1.